have this TMS simulation. We'll get the notebook LM to review it as well. There's no demo mode for this one yet. We are working on the demo mode. Can you fix the code, the layout of the page? Make sure the brain is actually loading. Make sure the canvas, the simulation canvas, is actually working correctly. I don't currently see any errors, but there must be, because the brain is not loading. The layout of the page can be improved, and the text below the canvas could be just like normal text. Like, can you get rid of those feature cards? I don't like them.
I'll fix the brain loading issues, improve the layout, and simplify the educational content section. The main issues are likely in the brain model loading and some missing elements. Index.html.
Okay, you can do that one quietly. So it's not in agent mode, it's in just edit mode. We are in Visual Studio Code. I know lots of people interested in the technical details. We are not. We're interested in the application, in the web application actually working. And we are developing in English. So the question about what code you use, well, obviously it's JavaScript, because it's available for you on the site. You can go check it out straight away. It's up and running. Just trying to fine tune a few things, but it's working okay. You can simulate your waves, enable precision targeting. You can target a specific area of the brain. This brain, by the way, yeah, it's a model available freely. Can download it and play with it. Here we're only loading, as you can tell, there's like missing things inside it. Well, that's because we're not loading all the brain parts, only loading some of them, just to reduce the. Anyway, everything we do appears on this side. I think I've already been talking enough. We'll get the robots to do the rest of the talking. Okay, with Notebook LM, the code for this web application, and it generated 5 minutes, which we're gonna listen to.
Okay, imagine this for a second. Using like invisible magnetic forces to actually change what your brain is doing, non-invasively.
Sounds a bit like science fiction, doesn't it?
Totally, but it's real. It's called Transcranial Magnetic Stimulation, TMS.
Yeah.
And it's already out there, helping treat different brain conditions, mental health stuff.
And today, we're going deeper. We're not just talking about TMS theory. We're actually diving into an interactive simulation. Mm-hmm. It really lets us see these complex brain processes happening. Visualizing it makes a huge difference.
Exactly. So our mission here is to kind of unpack how the different settings in TMS things, like, which coil you use, how strong the pulse is, how fast the pulses are.
The frequency.
Right. The frequency, how all that stuff actually creates real visible effects inside the brain. We want to find those like aha moments, the ones that show just how incredibly precise this technology can be, thanks to this real-time 3D view.
And that visualization, it's really powerful for understanding how changing one little parameter directly influences brain activity. Let's maybe start with the coils.
Good idea.
So you've got the figure 8 coil. That one creates a really focused magnetic field, very targeted.
Right, like aiming a tiny spotlight onto a very specific spot in the brain. Super precise. But then there's the other main type, the circular coil.
Yeah, the circular coil. It's different. It gives you a much broader magnetic field. Covers a larger area.
Okay, so broader, like a floodlight instead of a spotlight. Is that broader effect ever, better? Sometimes you want the floodlight.
That's a really good question. It depends. The figure 8 is great for that surgical precision, maybe targeting a very specific motor point or something. But the circular coil, that wider engagement might be better for, say, conditions involving larger brain networks, maybe certain mood disorders where you want a less focused effect. It really comes down to the therapeutic aim.
Makes sense. So it's not just where you stimulate, but also the rhythm of it, the pulse frequency.
Exactly. And the simulation shows this so clearly. Low frequencies, anything under, say, 5 pulses per second, 5 hertz.
Okay, less than 5 hertz.
Those have an inhibitory effect. They basically calm down the neurons in that area, make them less likely to fire.
Huh. Interesting. So it's like putting the brakes on. Does the simulation then show the opposite if you speed things up? What if you go above 5 hertz?
Precisely the opposite. High frequencies, so more than 5 hertz, they're excitatory.
Right.
They ramp up the neural activity, make those neurons more likely to fire. This control, this ability to either inhibit or excite is, well, it's fundamental to how TMS works therapeutically.
So we have the with the coil, the rhythm with the frequency. What about the strength, the intensity of the pulse? I'm guessing it's not just more is always better.
Definitely not. The simulation shows this really well, too. Cranking up the intensity doesn't just make the effect stronger in the same spot. It can actually make the affected area bigger.
Oh, right.
Or it might even start activating nearby neural pathways that weren't active at lower intensities. So intensity is another key dial for fine-tuning, controlling the volume of brain tissue you're affecting.
And the visualization itself, we see those cyan lines for the magnetic field, right? And that yellow ball.
Yeah, the cyan lines show the magnetic field shape coming from the coil, but that yellow sphere that shows the induced electric field inside the brain tissue itself, and that's crucial.
Why is the electric field sphere so important? I thought it was magnetic stimulation.
Well, the magnetic field passes through the skull easily. That's the non-invasive part. But it's the electric field that the magnetic pulse induces or creates inside the brain. That's what actually makes the neurons fire or not fire.
Okay, so the magnetic field is the tool, but the electric field it creates is the actual, active ingredient.
Exactly. Seeing that yellow sphere's location and intensity helps researchers know precisely where the stimulation is really having its effect, electrically speaking.
Wow.
It's more direct than just looking at the coil position. We also see heat colors on the brain model showing the intensity hotspots.
So pulling it all together, this deep dive really highlights how much control we gain by understanding these specific TMS settings. Knowing, okay, figure 8 for focus, circular for broader areas, and knowing that low frequency calms things down, high frequency ramps things up. It turns TMS from just a general concept into something you can really tailor.
That's the key insight. The power of visualization helps cement that understanding. You see, the figure 8 field is tight, the circular is wide. You see the inhibitory effect visually represented differently from the excitatory one.
It makes it tangible.
Precisely. And connecting this back to you, the listener, understanding these specific settings, seeing them visualized, it really gives you a window into the potential here. We're talking about highly targeted, non-invasive ways to interact with the brain.
Absolutely.
So again, this tool is also available on BioniChaos.com. You can go check it out yourself. Pop it in the link in the description. Yes, we did already pop the link in the chat. So there is that. And we got another one.